This is Lesson 102 in Saxon's Algebra 1 3rd edition book. This lesson is on absolute value inequalities, Lesson 102. Alright, I found this little cartoon. I liked it. Absolute values won't put up with negativity. Put any value but 0 behind bars and the results will always be absolutely positive. Alright, this but 0 is important. Okay, it doesn't apply to 0. Another one. We're at the blood bank and the person sitting in the chair says, "That's impossible. I can't have a negative blood type. That is because I'm an absolute value." Alright, the definition of absolute value is the distance from 0 on the number line. And the absolute value, just like distance, is always positive. So if you think of absolute value as a distance and not a number or numeral, it'll help you. So from 0, the absolute value of 3 is 1, 2, 3. Or the distance from 0 is 3. The distance from 0 of negative 2 is 2 places. That's why it is positive 2, because it's 2 places away from 0. That's the distance. Alright, you can see here in this, negative 3 is 3 units away from 0. Positive 4 is also 4 units away from 0. Okay, so how do we graph absolute value inequalities? Well, here's the different ways. This says the absolute value of x is 2. Well, since absolute value is a distance from 0, it can be both positive 2 and negative 2. So we're going to put a closed circle on both of those. Now that's an equality. An inequality means the absolute value of x is greater than or equal to 2. So we start just like we did up here. It could be positive 2 and anything greater than. It could also be negative 2 and anything less than, because if it is less than, it's, let's say, negative 3, and negative 3 would be 3, which is still greater than 2. Alright, here the absolute value of x is less than or equal to 2. Obviously, because it's equal then, we're going to put closed circles on both 2 and negative 2. But what's going to be less than 2? Well, 1 is less than 2. 0 is less than 2. But going this way from the negative side, this is 1 space. This is 2 spaces. Okay, 1 space away is less than 2. 0 spaces away is less than 2. Here we have x is greater than 2. The absolute value of x is greater than 2. Well, what is actually greater than 2? Well, we know that going right on the number line is greater than 2, 3, 4, 5, etc. It is not equal to, so we put an open circle on 2. We also put an open circle on negative 2, and anything going further away from 0 is going to be the distance is going to be greater than 2 from 0. But in this one, the absolute value of x is less than 2. We're going to put our open circles on both 2 and negative 2, and then it's everything in between those two numbers are less than. I want you to put in your notes this page. I want you to copy it. It will give you a good example to go by when you are having to graph these problems. So let's do some graphing. Okay, this says that absolute value of x is greater than 2. It's not equal to, so I'm going to put an open circle on both 2 and negative 2. Well, I know that going this way I'm getting further from 0, so that's greater. But going this way I'm also getting further away from 0, so that's going to be greater. It's going to be more spaces from 0, so it's going to be greater than. So that would be the correct graph for this. In this example, I have the absolute value of x is less than or equal to 3. Because it is equal to, I'm going to put a closed circle on both 3 and negative 3. And what would be less than? Well, here it's going to be this way, and here it's going to be this way to 0. So my line connects in between those two. Alright, this situation is going to be a little bit different. Here, we actually don't have a solution that we can graph because there are no real numbers that would satisfy this condition. The absolute value of x is less than negative 4. Because if I tried to say that it was, let's say, if I put an open circle here, less than negative 4, absolute value of x is less than negative 4, well, everything that's actually less than negative 4 is going to be going this way, according to what we've always known. But none of these numbers are going to satisfy that solution as being less than negative 4 when you're talking about absolute value, because if you go the traditional less than way, you're getting further and further and further from negative 4. So in this case, we're going to say that there is no solution, or that it is an empty set, a null set. You can also write it like this: there is no solution. Alright, this one is also a little bit tricky. It's also a little different, just like the last example that we did, where it said x, the absolute value of x is less than negative 4, and there was no solution to that set. In this one, we have to consider that every single number, every single real number on this number line could be a possible solution to this statement. Alright, so let's try putting in a number. Let's say we try negative 6. The absolute value of negative 6 is greater than negative 4. That is a true statement. Alright, let's try saying that the absolute value of 2 is greater than negative 4. Also a true statement. So no matter where we go on the number line, it's going to be a true statement. Let's try negative 1. The absolute value of negative 1 is greater than negative 4. Well, the absolute value of negative 1 is 1, and 1 is greater than negative 4, so that is also a true statement. So here we're going to draw a line that encompasses everything, and we'll continue going in both directions. So again, that may be one you want to put in your notes, these last two, to refer to. In this example, we are going to say negative, or let's use the word opposite. The opposite of the absolute value of x is greater than or equal to negative 3. All right, in this one, we're going to start with, because it is, we do have equal to, we're going to put a closed circle on both of the 3's. All right, and then we're going to, let's say we choose one of these numbers. Let's say negative 1. The opposite of the absolute value of negative 1 is greater than or equal to negative 3. All right, the absolute value of negative 1 is 1, and the opposite of 1 is negative 1. Is negative 1 greater than or equal to negative 3? Yes, it is. That is a true statement. So we know that any of these are going to fit in our description, in our solution set. Let's try another number. Let's say the opposite of the absolute value of 2 is greater than or equal to negative 3. Well, the absolute value of 2 is 2, and the opposite of 2 is negative 2. Is negative 2 greater than or equal to negative 3? Yes, it is. That is also a true statement. So, our line will just go between the positive 3 and the negative 3, and that will be our solution set for that. In this example, the first thing we're going to have to do is sort of semi-solve this equation because we have numbers on both sides. So we need to move this negative 2 to the other side first. We've gotten rid of that. We have the opposite of the absolute value of x is greater than negative 3. Now remember, we learned a while back that if we have the negative on the outside, a negative exponent, a negative variable, that what we actually have to do to this symbol is reverse it. I should have done that in the last example also, but I worked it out for you to see why. So what this is actually going to be graphed as is x is the absolute value of x is less than 3 because we divided by negative 1 when we had to divide by negative 1 on both sides. Remember, we have to reverse the symbol. So this is what we're actually going to be graphing. The absolute value of x is less than 3. It is not equal to 3, so we're going to put open circles on both of the 3's, and it will be everything in between. Okay, let's do our practice problems. So just like in our last example, we are going to have a situation here because of this that we're going to have to reverse this symbol. But the first thing we have to do is move this 9. So we're going to add 9 to both sides of this equation or inequality. And we have the opposite of the absolute value of x is greater than negative 2. But then we have to divide everything by negative 1. And then we have the absolute value of x is less than 2. So the absolute value of x is less than 2. So we're going to put, because it's not equal to, we're going to put open circles on both 2 and negative 2. And it will encompass everything in between those two as our solution set. Don't forget to reverse your sign. Alright, in this one we have the absolute value of x is greater than 0. Well, it doesn't include 0. Obviously, if it's greater than 0, we know it's going to the right. But in this case, if we were to put negative 6 in the place of x, the absolute value of negative 6 is 6. And 6 is greater than 0. So negatives, all the negatives would apply as well. So our graph is going to look like this in this case. Only 0 is excluded. Alright, this can be a little tricky. Please take good notes. Keep these things in your notes so you can refer back to them. And I'll see you next time for Lesson 103.